everyone, welcome to This Explainer. Look, if you've ever worked in or managed a modern IT environment, you know the absolute headache of manual configuration. Clicking through endless menus, configuring virtual machines one by one, typing out network settings by hand. It's slow, it's tedious, and let's be honest, it's incredibly prone to human error. But today, we're going to fix that. I want you to think of the modern data center not as a cold room full of blinking servers, but as a factory. In the old days, every product in a factory was built by hand. Today, it's all about high-speed assembly lines, precision, and robotics. So we're going to climb the ladder of automation within VMware's toolkit and show you how to transform those manual, everyday IT tasks into a fully automated, self-healing factory.
Okay, let's dive right into this. Here's our roadmap for the climb. 1. The automation imperative. 2. Scripting with PowerCLI. 3. Orchestrating workflows with VRO. 4. Infrastructure as code. And finally, 5. Automating Kubernetes and Tanzu. All right, starting at the foundation. Section 1, the automation imperative.
Before we look at the specific tools, we really need to get our definition straight. A lot of people use these two terms interchangeably, but they are very different things. Automation is about executing routine individual tasks, like provisioning a single virtual machine or assigning an IP address. Think of automation as a single, highly efficient power drill on the factory floor. Orchestration, on the other hand, is managing complex, multi-step workflows. It takes dozens of those individual automated tasks and coordinates them into one seamless process. So if automation is the power drill, orchestration is the entire assembly line running from start to finish without anyone having to push a button.
Moving up to step 2 on our ladder, scripting with PowerShell. Seriously, just imagine the absolute nightmare of provisioning 100 VMs by hand. You'd be clicking through the vSphere client for hours, and chances are you'd mistype a configuration on at least one of them, right? Well, PowerCLI completely cures this. Its real superpower is batch operations. With just a single command line script, you can deploy a new VM for every single department in your company and automatically apply the exact right resource configurations for CPU, memory, and storage. Plus, it handles centralized monitoring and reporting, so you can pull performance data across all those VMs at the exact same time.
Now, if you're prepping for a certification exam or just building out a rock-solid environment, definitely pay close attention to this. PowerCLI isn't just about running basic commands. It integrates on a deep level with the vSphere REST API. By tapping into that API, PowerCLI can programmatically automate complex vMotion and Distributed Resource Scheduler, or DRS, decisions. A script can constantly monitor your VM load, trigger a policy the second CPU usage spikes, and use an API call to just seamlessly migrate that VM to a host with more available resources. It's brilliant. So the crucial point is, how do we keep these incredibly powerful scripts from causing utter chaos? That's where role-based access control, or RBAC, becomes absolutely paramount. When you've got scripts that can delete or modify hundreds of VMs in a matter of seconds, security is literally everything. RBAC enforces strict policies so a script can only execute within very specific boundaries. For example, another great exam focus. You can configure RBAC so a PowerCLI script only has permission to touch VMs in your development folder. That physically prevents it from ever accidentally wiping out your production workloads.
All right, up another rung. Section 3, orchestrating workflows with VRO.
VRO, or vRealize Orchestrator, is where the magic of self-healing IT environments really comes to life. A massive concept to grasp here is event-driven automation. VRO relies on specific event triggers that actively monitor changes happening in vSphere. Let's say a data store hits 90% capacity. Normally, an admin gets woken up by a pager at 2 a.m. to manually add storage. But with VRO, an event trigger catches that 90% threshold and automatically kicks off a workflow to provision more storage. The problem gets completely solved and nobody even had to wake up. And this brilliantly illustrates how VRO actually fits into the larger ecosystem, particularly with vRealize Automation, or VRA. You see, VRA is basically the front-end storefront, where a user just clicks, hey, I need a new web server. But VRO is the back-end engine actually doing all the heavy lifting. It catches that request, provisions the VM, configures the network VLANs, installs the software, and locks it down with security rules. It literally turns a process that used to take days into something that finishes in minutes. Moving right along to Section 4, Infrastructure as Code. Infrastructure as Code, or IAC, is all about treating your hardware setup exactly like software. And to really master it, you have to understand the sharp contrast between the declarative model and the imperative model.
In the older imperative model, you had to write out the exact painful step-by-step instructions to build your setup. But modern IAC relies heavily on the declarative model. With this, you simply declare your desired final state. You basically just say, I want 3 web servers looking exactly like this, and the IAC tool figures out the actual steps to make reality match your code. It cuts out the manual configuration entirely. Now, when you're working with Terraform, which is easily one of the most popular IAC tools out there, understanding its state file is absolutely critical. Terraform uses a language called HCL to manage vSphere, but the real secret sauce is the Terraform state file. Because you're using a declarative model, Terraform has to know what your data center currently looks like so it can compare it to your code blueprints. The state file meticulously tracks all these changes to prevent infrastructure drift, which is that sneaky situation where your actual environment quietly changes over time and no longer matches your official code. Now, what's really interesting about this slide is how it helps you navigate the crowded landscape of configuration management tools. Huge exam-focused tip here, look at the agentless column. Tools like Ansible and SaltStack are agentless. That means you don't need to install any background software on the target machines to manage them, which makes them incredibly easy to roll out. On the flip side, agent-based tools like Puppet and Chef do require you to install software agents, but they are absolute beasts when it comes to rigorous long-term system management and complex application deployment. The really cool thing about using Terraform in the VMware ecosystem is that it doesn't stop at your local data center. Not even close. Terraform gives you a single, unified tool to cross the boundary right into the cloud. You can use the exact same logic you use on-prem to provision VMware Cloud on AWS, to spin up vSphere Kubernetes clusters, and even to configure complex NSXT software-defined networks. It's literally one language to rule your entire hybrid cloud setup. And that brings us to the very top of our ladder, Section 5, Automating Kubernetes and Tanzu. We all know Kubernetes is incredibly powerful, but man, managing multiple clusters spread across different environments can get messy really fast. Enter Tanzu Mission Control, or TMC. Think of TMC as your centralized command center. Make sure to note this, it completely automates the lifecycle management of your Kubernetes clusters, whether they're sitting in your basement or out in the public cloud. And best of all, when it provisions a new cluster, it automatically bakes in your organization's security policies from second one, so absolutely nothing goes live unprotected. Let's bring it all together and see how this builds into a fully self-service Kubernetes environment. Step 1. A developer requests a cluster through the Aria automation portal, which you might remember as VRA. Step 2, the backend system immediately triggers Terraform to automatically deploy vSphere with Tanzu. Step 3, Aria automation wraps the whole thing up by enforcing all your strict network and security roles. The developer gets their brand new cluster in minutes, and the IT team literally didn't have to lift a finger. So what does this all mean? We've covered an incredible evolutionary leap today. We started way down at the bottom, fighting manual tasks and typos, and climbed all the way up to fully automated, self-healing, self-service Kubernetes clusters driven entirely by code. I want to leave you with this provocative question to really think about. Where is your data center currently sitting on this ladder of automation? Are you still provisioning by hand, or are you ready to write the code that builds your factory? Take these concepts, start implementing them, and get ready to scale your infrastructure like never before. Thanks for hanging out with us for this explainer, and keep learning.